Hello. So let's look at graphing radicals with reflections, okay? What happens if you have a negative sign with the radical? So I took the liberty of putting f of x, g of x, and h of x up here. F of x is the square root of x. G of x will be the negative of that square root of x. And then h of x will be the square root of a negative x. So we're going to see how all this plays out. So first let's take a look at what I call the base graph, okay? This f of x equals the square root of x. So if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. If x is 4, the square root of 4 is 2. If x is 9, the square root of 9 is 3. So notice on my x's, I didn't just keep going 1, 2, 3, 4, 5, 6, and so on. Because 2 and 3, I wanted perfect squares. That's why I skipped to 4 and 9 here. So, graphing these guys, if x is 0, y is 0. Or f of x is 0. If x is 1, my f of x is 1. If x is 4, f of x is 2. And if x is 9, f of x is 3. So we see our graph right there. Okay, now let's see what happens if I put a negative in front of all that. Well, I'm using the same x values again. Square root of 0 is 0. The square root of 1 is 1, but then I take the negative of that, so it'll be a negative 1. Square root of 4 is 2. I take the negative of that, it'll be a negative 2. Square root of 9 is 3. I take the negative of that, it's a negative 3. So what happens is, if x is 0, y is 0. If x is 1, y is negative 1. If x is 4, y is negative 2. And if x is 9, y is a negative 3. See what just happened there? It's a reflection. It's a vertical reflection across the x-axis. All right, so when you see a negative in front of your square root like that, that's what's going to happen. All right, now let's take a look at what happens if you have a negative inside the radical. Now notice my x values have changed. I can't use 0, 1, 2, or 0, 1, 4, and 9 again because, for example, if I tried 4, the square root of negative 4 would be not real, which would open a whole different can of worms I'm going to get to in some other video. So instead, I'm going to use negative values here. Well, square root is 0. Square root of a negative 0 is still 0, so that's not a big deal. The square root of a negative 1 is really the square root of 1, which is 1. The square root of a negative 4 is the square root of 4, which is 2. The square root of a negative 9 is the square root of 9, which is 3. So let's graph these. I've got 0, 0 again. Then I got negative 1, 0. Excuse me, negative 1, 1. Negative 1, 1. Negative 4, 2. And then negative 9, 3. So it's not quite drawn to scale, but hopefully you get the idea about what's happening here. My blue graph, remember that was my base graph. It's now flipped horizontally about the y-axis. So if you've got a negative inside the function that you're working with here, right, inside the radical in this case, then you're going to see it move horizontally. If you have a negative outside the function you're working with, you'll see it moving vertically, okay? Incidentally, if you had, I'm going to have some fun with this. Let's go k of x. Suppose that was negative of a negative x. You guys think you know what's going to happen there? Yeah, we got a double reflection. It's like watching a gymnast or a diver in the Olympic swimming meet. Right? It's a double twist. He does this, and then he does this. So there you go. That's what it's going to look like. It's a double reflection. Pretty cool, huh? Yeah, I thought so.